Hello everybody, Nick the Tiro here. It's time we start talking a little bit about data structures. And basically data structures, if you're interested in it, we do have a HIT class here at Lakeland. We don't go into that deep into these courses, but it's how you arrange your data. And for this course, we arrange our data as in either an array or a list. Now, if you're in taking Python, Python does not have arrays. So in Python, we use list, and in other languages, we will use arrays. But fundamentally, what are they? They're not, first of all, it's not interchangeable, but they're fundamentally a collection of items or a collection of the same items that we can reference to them. Now, throughout the course of this video, I'm going to be using a lot of metaphors, but they're not really metaphors because this is how we would actually apply the concepts of a list or an array. So let me jump up to my screen here. And this is a Google Earth view of Lakeland Community College. And we can begin to use the metaphor, but more in reality, this is how we'd actually program. If you look around the campus, we have parking lots. All right, all over campus, we have parking lots. And if I zoom into any one of these parking lots real quickly, if you pay attention to things, and I encourage people to really start paying attention to things, this picture, this Google Earth picture, was probably taken early May. If you notice this big white thing here, that's our graduation tent, which usually goes up about a week before commencement, and then it comes down about a week after commencement. So that's early May. So kind of a little investigation there. But we have parking lots, and I'm going to zoom in on these parking lots. And you'll notice that the parking lots are pretty structured, right? We have cars in parking spaces. Some parking spaces are empty, but basically the structure of the parking lots are consistent. Now, if I scroll over this way, this is the faculty lot way over here. And you'll notice that we have some cars. I'll zoom in some more. I don't think my car is here. I'll zoom in some more. And you'll notice that we have cars parked in specific positions. Now, in an array, when we build an array, we tell it the specific number of spots available, right? And that takes a lot of planning. You'll see me do that in a little bit. But in array, it is pretty much a fixed spot. Doesn't really matter so much how many cars are in that spot, but it's more importantly that we have all these spots. So let's say hypothetically, this particular parking lot holds 100 parking spaces. That means that regardless of the number of cars, if I only have one car in there, the parking lot still holds only 100 spaces. And there's reasons that we use arrays versus a list. Now, let me go to another area. This is an aerial view of the Geauga County Fairgrounds. And you'll notice something. I mean, where's the parking spaces? First of all, if you've not been out to the Geauga County Fair, it's absolutely fabulous. It's really kind of a cool place to go. But where are the parking lots? They have these minor little parking lots over here. It looks more for employees. But if you go to the fair, you will notice that there's literally hundreds of cars parked in these green area. And if I zoom in on them, scroll around, you'll actually see where they're kind of the lanes are burned, but there's no specific spots. This is more of a tune to a list where we basically would be putting cars pretty much anywhere. Now, we would still be able to reference those cars in a specific order, but you'll notice that we don't have a fixed amount. So maybe on a busy day, they can fit in this particular area. Maybe on a busy day, they can fit 200 cars. Maybe on a normal day, it's 150 cars. So there's actually no spaces specifically assigned. So your question is, which is better? Is the array better or the list better? And it's really about what you're going to use. For a array, you have to plan this out, right? But because you plan it out internally to the computer, it's very efficient because the computer knows there's only going to be 100 potential cars in this given array. So the planning, the pre-planning takes a little bit more effort, but the implementation of actually using it is a little bit more efficient for the computer. So, but if we go back to my list analogy, you might say, well, this apparently is more easy to understand. Not really. See, if you go out to the fair, there's some overhead to this style of parking. There's usually like 5 to 10 people who work for the fair that are directing cars and telling people where to go. And then, you know, when you're done with the fair and you come back, you might have to ask somebody specifically where something is. And it will often follow a last in approach where they're just putting more and more people there. So the overhead on this one is a little bit more to a computer. So the overhead on lists are a little bit more computer. If you're in programming logic and you're using Python, right? If you're using Python, Python doesn't use arrays. Native Python does not use array. Native Python use list. But in the demonstrations I'm going to do in a little bit, I will be concentrating on the specifics of either Java or for Python. Okay. I don't want to keep harping on this, but I think it's an important topic. So this will be pretty much one of the last times. Native Python does not use arrays. Arrays are a fixed structure. They're a fixed data structure. So if I'm creating a parking lot, and when I create that parking lot, there's 100 parking spaces in that lot. If I need to expand it, I would have to rebuild an entire new parking lot. Doesn't matter how many cars would be in that parking lot. Maximum number of cars would be the number of spaces, so 100. But if there's no cars in there, the parking lot or the array still is a length of 100. If there's one car in there, it's 100. It doesn't really matter. So native Python does not use arrays. Python uses lists, which are a little bit different. If we keep following this analogy, it is that big open field that people park in for events or the fair or concerts or something like that. They're not striped and they're not organized. And then they have people standing there going, you park over there, you park over there. That is what a list is. So I want to use this part of the video, to demonstrate a whole bunch of lists and how they particularly work. So let's go up to my screen. And because I want to do a whole bunch of demonstrations, I'm going to go back to my Python interpreter. And the first thing I'm going to do is I'm going to create a field lot A. And to make it a list, I'm going to use the square brackets. Hit enter, and I've just created a list called field lot A. There's nothing in there. If I was to say, show me what's in there, because I'm in the interpreter, I can just do this. It's showing me there's nothing in there. If I say, show me the length, len, show me the length of field lot A, length of 0, right? It doesn't begin to have a length or any kind of value until something is in there. So what I want to do is I want to park the first car in there. So I'm going to say field lot A dot append. We're going to use the method append, and I'm going to give it the car name. We'll call this one a Ford. Right. Now, if I do a field lot A, it shows me there's a Ford in there. If I do a length of field lot A, it shows me as 1. So the size of the field, the size of the lot, is going to expand or contract based upon the number of cars that we're going to put in there. Let's say I want to put another car in there. So somebody's directing, go park over there. Well, I can use what they call the append method. I can go field lot A, append, and this time I'll put a Toyota. Append puts an item in the list at the very end. So now if I do a field, if I say, show me what's in there, it's showing me that there's 2 in there. Here's where things can get just a little bit tricky. What if it's a hard analogy. What if I wanted to put something at the very beginning of the lot? Say there was a little bit of space left there that when the Ford parked there, they left a little space. Could I insert something in there? Yes. What I can do is I can say field, spell it correctly, field lot A, spell it correctly, insert where? Well, here we have to use our indices. So that first indice is the 0 indice. So I would say at position 0, insert a BMW. And again, if I do a field lot A, it shows me the BMW, the Ford, and the Toyota are there. If I needed to remove items from the list, I can remove them in several ways. Let me clear my screen before I go on any further. Say I wanted to remove that Ford. Now, again, the analogy or the metaphor doesn't work too well because what's going to happen is if I remove the Ford, the Toyota is going to shift over. But let me do that. Let's say I want to remove one of the items in that list. Can I do that? Oh, absolutely. Now, our metaphor or analogy doesn't work too well. So let's say I want to remove the Ford. I know if I just double check everything one more time, we see that Ford is in the second position, which is really indice 1. Remember, when we count indices, we always start at 0, 1, and 2. I want to remove Ford. Now, where the metaphor doesn't work is you're going to see the Toyota shift on over there. So it's not going to leave that empty space. So what I can do is I'll say delete field lot A, the item that is in that second position or the first indice. Now, if I look at it again, you can see that the Toyota. So the lists tend to be very dynamic, and as you're working with them, you want to be careful about moving things around. You can insert, you can append, you can delete, you can sort, you can do a wide variety of things with a list. What are some other potential lists that we can do? How about a desk in a classroom, or more students in a classroom? I can say classroom. Spell it correctly. Let me clear the screen. We can say classroom A students. And right now, we didn't put any students in the classroom, but we can say classroom A students, append Bob. Do the same thing, but this time we will append Alice. And if I just take a look at that classroom, we can see that Alice and Bob are in there. Can I create a list with values already in there? Absolutely. Let me clear my screen. And let's expand upon this. I want to build, I'm going to do a demonstration in another video, but I want to build a bunch of lists that their organization parallel each other. They correspond to each other. So I want to create a list about class names where we got, what do you call it? Freshman, sophomore, junior, senior. Can I build a list based upon those 4 names? Yeah, I'll call it class name. And that's going to be equal to, now this time I'm not going to do an open and close bracket. I'm going to do an open bracket and I'll say freshman, sophomore, junior, and then senior. And if I just say what's in there, again, I'm at the interpreter. Can I iterate through a list? Absolutely. A list would be useless, not fundamentally useless, if we couldn't iterate or we couldn't do stuff to it. So one of the easiest ways in Python that I can iterate through the list is I can say for, I can give it a variable, and I'm going to call this variable just item and spell it correctly. And I'm going to say for the item in class name, print the item. And you can see that it iterated through the classes. It printed freshman, sophomore, junior, and senior. Another way I can do it is, let me clear my screen. I can give it a range. I can give it a value. I can say for I in range 4. Now, I will tell you right away, Be careful about hard coding the size and the length of a list because it can change. I'm doing it here as an example, but what this is saying is this for loop is going to iterate through a range of numbers up to 4. All right, so 0, 1, 2, 3, all right, up to 4. It's going to stop before it gets to 4. Remember, I'm going to keep stressing this. Indices start at 0. So this says for I in range to 4, 0, 1, 2, 3. That's how many iterations. So it's going to go 4 iterations. It's going to go through 3. It's going to stop at 3. And then what happened there? I must have hit a key. That was interesting. Must have hit the key by accident here. And I'm going to say here, a tab over, I'm going to say print class name, give it the integer I, and run it. And we iterated through there. This time I was very specific. I said, go after these particular indices at this given point. How about, can I do it without hard coding it? Let's say, for example, I don't know how big that list can be. As you look out at that parking field, there could be hundreds of cars in there. How can I do that? I do that with the length. If I just do a length on class name, it shows it at 4. That might be a better way for me to iterate through. So I can say for I in range, the length of the list that I'm working with. So instead of hard coding 4, I'm saying based upon the length that the computer is going to determine, and do the exact same thing. Print class name I. Oh, too many open parens. Let me try this again. Print class name, the indice, just one paren. That's what was causing the problem. And it iterated through. Sorry for the typos. So you can see that I'm actually doing this. It's not smoke and mirrors. All righty. But I said I want to create a situation where I want a bunch of lists that work together, and maybe we can do some calculations based upon the items in the list and stuff like that. Right now, I have just been using the string. I've been using a list of strings. Let me clear my screen here. All right. Can I do it with integers? Can I do it with doubles? Can I do it with floats? Can I do it with, yes, you can. The thing with strings is, and I don't advise it early on in your exploration of this topic, is a string can hold any variable in it. You could have a string that has integers, doubles, strings, and stuff like that. You can't do that with arrays. Arrays are very specific. You have an integer array, you have a string array, you have a double array. List, I can basically put anything I want in there and I can mix and match them. At this stage of our development, let's not worry about that. So I created a list called class name, and then I put in freshman, sophomore, junior, senior. How about class year? So I'll do a list called class year, and this one will be an integer of 1 for 2, 3, 4. So it's a list of just the year of the class. So, class freshmen are 1, sophomores are 2, juniors are 3, seniors are 4. How about, let's get a little interested here. How about we have a high school, and that high school has a total number of students is going to be equal to 1,000. So there's 1,000 students in that high school. And instead of giving you specific numbers for the students, the school just gives you percentages of students. So we're going to say, we're going to create a list called percentage of students. And that's going to be, we're going to say there are 30% of the students are freshmen. 27% of the students are sophomores. 23% of the students are juniors, and 20% of the students are seniors. You often see this in high school. There's often more freshmen than there are seniors, and it just kind of works there. So now I have a couple pieces of information here. I have a couple lists. If I do percentage of, spell it right, Nick, students, it shows me that I have this list of the percentage of students. Can I create a list based upon other information? Absolutely. Again, it would be meaningless if we were only using these things as fixed things. I could expand the list, I can contract the list, but I could actually build elements within that list based upon other information. It's a great place to work and store things. So we want to create a list of how the students are distributed, right? And that distribution is going to be based upon multiplying the total number of students times the distribution, percentage distribution. And we're going to take that information and we are going to create a list based upon that information. So we're actually going to be going through one list to create another list. And we can do that. The first thing I'm going to do, I'm going to create that distribution list. I'm going to say distributed students. And right now, it's empty. Okay? Typos, Nick, typos. And right now, it's empty. And now what I'm going to do is I'm going to clear my screen. I'm going to run through a for loop. Now, let's bring back a little bit of our knowledge from previous discussions, our discussions about definite loops and indefinite loops. And we said a definite loop is usually used, and that would be a for loop, is usually used when we can relatively easily determine the number of iterations we're going to go through. And an indefinite loop, which is our while loop, we use that when it's difficult to determine the number of iterations that we go through. So a for loop is a really good use inside a list because we can generally determine how many iterations we can go through by just doing a length on that list. No matter how big that list is, if I say iterate through this entire list based upon the size of the list. Now, sometimes we could potentially use a while loop where you say, go through this list until you find the white Ford, right? But for our demonstrations here, since I know how many iterations I'm going to go through, we know that each one of those lists is 4, I can use a for loop. I can use a definite loop in this regard. So I'm going to say, I'm going to use some of that Python shorthand, right? I'm going to use for percentage in percentage of students. All right. So go through the entire list of percentage of students. And every time you grab an item, what you're going to do is you're going to create that distributed student list. So I'm going to say distributed students. So let's iterate through the entire list. And what we want to do is we want to create a new list based upon information on other lists. So what I want to do is I want to look at each one of those percentages, the distribution percentages, calculate how many students are in that given class based upon 1,000 times the distribution percentage, and then take that result and put it into a new list. And the new list, I'm going to call it distributed students. I'm going to make it empty. All right. And let's go through the loop. Let's go through the loop. We'll say for I in range. And range of what? Well, we know percentage of students. That's that list that has the items that are basically percentages of the class. So for I in the, not the range, but the length, a percentage of students. Make sure I type it right. So I is going to start at 0, and we're going to determine the length of percentage of students, which is 4. Could I have just typed 4 in there? Yeah. We don't want to get into hard coding, right? So we determine the length. Range is going to go all the way up to, but not include that last value, because indices started at 0. 0, 1, 2, 3. 4 items are going to go through, but we're going to stop at 3. And here, what we're going to do is we are going to populate, or we are going to create a new list, right? And that new list is that distributed student list. So what I can say is distributed students. And how do we put things on the back of a list? We're going to use the append. So distributed students dot append what? Append percentage of students at I times total number of students. Okay, so we know that's equal to 1,000, right? We don't want to hard code 1,000 in there because we can fluctuate here. So let me make sure all my parentheses, open and close parens, line up, and no, they do not. All right, so we're going to calculate 1,000 times the distribution percentage, and whatever value we get there, we're going to append that to the distributed student list. All right, let's take a look at the distributed student list. So we have 300 students, 270 students, 230 students, 200 students. You'll notice that it is a floating number because, whoops, where am I? I must be hitting something. Could I do this as an integer? Yeah. What I can do is I can typecast it to make it integer values. Let's do that. All right. What are we going to do? We're going to say, we're going to clear my screen first. All right, and we're going to start over from scratch. We're going to say distributed students, going to be completely empty list again. We're going to do the exact same for loop. We're going to say for I in range, and the range is going to be the length of percentage of students. Make sure all my, so that the length of percentage of students is 4. So we're going to iterate through this loop 4 times, starting at 0, 0, 1, 2, 3. Keep talking about that. And this time, I'm still going to do the append, but I'm going to do distributed, type it right, Nick. Distributed students dot append. And this time I'm going to say, I'm going to typecast. I want the integer. I don't want it to be a float. I don't want it to be a double. So this time I'm going to typecast it with the integer, and I'm going to say, what is it? Percentage of students I. So we look at the indice, we grab it, and we're going to multiply that by total number of students. And then we're going to make sure all my parentheses line up. So let's do the calculation here. That's going to get a floating number or a double. And then we're going to typecast it in, and we're going to append that to distributed students. And now if we look at distributed students, we can see that there are integer values there. So we went through a whole bunch of examples here. We created empty list, we populated list, we then created a list based upon some kind of calculation. What are some other lists that we can do? Pages in a book, post office boxes. How about, trying to think, books in a library? These are all methods that we can use, or all things that we can simulate using list here. So let me wrap some things up. Okay. Hopefully I provided a lot of examples there. I think when we get into this type of area, especially with data structures and stuff like that, it's best if we just throw a lot of examples so people can really concentrate on the examples and potential use, the application, versus, the mechanics and things like that. So in other videos, we'll actually apply the knowledge that we gained from this video. But for this video, a lot of examples so we can understand it. That being said, hey, let's go on and learn something.